Tonight is October the 21st, 2022, and I'm going to make a video that was suggested by a good viewer the other day. I have my new kitty in here. Hope she's not too vocal. And I think it was in reference to this amplifier. This is a Heathkit WA-1. It's an amazing performing amplifier. I may have to take her out, huh? But he wondered how it would perform like with an 83. An 83 is a Mercury Vapour rectifier. Right here. Got one. And it's a good one. The 83 is has the same current rating as like a 5U4, about 250 milliamps. I have some others, some called 82, which is 125 milliamp current rating, which is about the same as a 5Y3. But anyway, what I'm going to do in this amplifier right here, a really nice performing amplifier, uses a little peerless output transformer. It's a Williamson design. I'll talk more about that when we look under it, but we'll make some voltage and power ratings with the 5V4, which is right here. And then I'm actually going to go to the trouble, because it's not that hard, and I'm going to swap out the octal socket for a 4-pin socket, and I'm going to leave this one in there for a while just to play with. So I'm going to actually install this one. You can operate these on their side. They say vertical position only, and what they're really saying is that when you first turn an MV rectifier on, you have to let it warm up long enough that there's no mercury on the cathode, because that apparently does some damage to it. But in the TV7 tube tester, they actually operate it horizontal, and it works just great. Been in there since, 1960. That's the kind they use in there, the 83. I think you can read that number right there. Okay, so let's get started. It's warmed up. 2 6SN7s, a pair of probably World War II vintage 807s. I had to change out the plate caps on them. They had little plastic plate caps and they melted to it, and when I pulled it off, I pulled the metal plate cap off. But I've had that happen many times, and as long as you don't break the glass, you can heat the top of the plate cap up while it's off, and get the solder off of it, straighten out the wire, put it back on, and I put a little quick drying epoxy glue on it and glue it back on, solder it back on. It works great. Just don't break the glass. Okay, well, let's see. We want to here's what we want to record. Here's what I think I'll do this time. We're going to do the 5V4, a 5U4, a 1620, a 1N2632, and the 83. 1N2632 is these solid state replacements, these octal sockets. So we want to do all the octal stuff first. We measure the DC voltage, and we measure the power output at 1%. We're just right below clipping, right at 1%. Okay, so now what we have to do is plug this guy in. I don't know what he's set up for right now. And we're going to, let's see, we want to measure the voltage. Oh my goodness, I have a complainer in here, don't I? I think I'll show you my kitty cat, and then I'll take her in, because she's probably going to torture us. She came to me all by herself. She's one of these kitty cats, if you can notice, with a clipped ear. See, her right ear's been clipped. And she's young and full of, and nuclear powered. But what they do around here, the Sun City cats, as they're called, they catch them, they neuter them, they give them vaccine, and then they turn them back loose where they caught them. But that's what we've got to go through. I'll be back in the blink of an eye. Okay, getting started again here. Let's measure the voltage, the plate voltage. I've already got the bottom off of this thing, so it's we can get out everything nicely. Using a little bit safer clip lead this time. Plate voltage is right here, and it is 480 volts. 479 to 480 volts. 478, you know, 400, okay, we're right down as whatever it is when I get my pencil. 478. 478 V's for the 5V4. Okay. I'll just leave this guy laying there. Let's set it back down. And let's see what kind of power we get out of it. We're just going to make simple power measurements here. We're not going to get too exotic. I do like for you to be able to see everything at once. And it's this one right here. It causes all the glare. Okay, we've got to plug our drive back in. And it's down here, sorry. I don't have all this set up, but nothing is ever easy. 24 watts. Okay, it's clipping there. So let's turn it back down. We'll watch the 1% up here. I believe you can see the THD. Yes, you can. It's 0.85. We'll run it right at 1%. Close as we get there, 1.2. It's really touchy. That's much to overdrive it. Okay, we'll call it that. 22 watts. We'll round it up. Okay, the power is 22 watts. We could do all kinds of other tests on it, but you know, it'll just make the video really long. So I'm going to stop it now. I'm going to put the 5U4 in there, and we'll do the same thing again. Okay, now we have a 5U4 in there, a good one. I'm careful, I want all this to be really legit. There's our 5U4. And our plate voltage now, the same point we were measuring it a while ago, that's just red lead right here, is 442 volts. 442. We'll go all of this in a minute. 442. And the power at 1% is, I believe I can scoop in on just a little wee bit so you can see that better. You'll need to see that top one. Here's 0.8%. Try just a little bit. Let's see if we can. There we go. That's real correct. We'll even give the old 5U4 the benefit of the doubt here. 0.9. I think that's what we were about. There we go. 18.77 watts. We'll call that 18.8 watts. 18.8. 18.8 watts. Okay, now this doesn't take any warm-up time, so I'm not even going to go off this time. I'm just going to go right back around here and show you the 5U4. And we're going to pull it out. We're going to put in one of these solid state diodes. I have two here. Let me show you. There's two different kinds. One is a 1N2632, one is a 1N1239. They're both rated at 2800 volts PI. We get a half amp. So that's twice the current rating of a 5U4 type tube. It's the high voltage version of a 5R4 is what it is. Okay. Put that in. By the way, all my capacitors can withstand this voltage. I've already made all those measurements. I don't want to blow it up. I don't have any intention of blowing my stuff up for no good reason. We'll give it just a second just to make sure that, well, just to make sure that, you know, the 807s are settling down and drawing their plate current from a little bit of heat. But look what our high voltage has risen to, 510 or 11 volts. That's pretty high, isn't it? Yeah, the capacitors can take it. We're okay there. I'll show you underneath the chassis, the power supply chassis in a minute. They have 800 volt capacitors now. 513 now. 500. Well, let's write it down to 512 volts. 512 volts. Okay, without touching the gain of the input to the amplifier, we can already see that. Let's see, what are we looking at here? the oscilloscope right there. We can already see that the THD has dropped to 0.5% without changing anything else. It's just swapping out that rectifier, and it rose to 19.3 watts from 18.8. Not a big deal, but it did rise. That's why I just got back up to 1%. There's 1%, 0.99, 26.45. Wow. Okay. 26.45 watts. So we went from 22 watts with the 5V4 to 18.8 watts with the 5U4 to 26.45 watts with a solid state. Okay, now that's that. Now, in the blink of an eye again, it'll take me 10 or 15 minutes. I'm going to swap out that octal socket for a 4-pin socket and be right back. Okay, getting back on the plan here. Here, let me turn this light out so you can see that that beautiful 83. There it is. I must doubt that's Mercury Vapor Rectifier, huh? I'm not trying to oversell these MV rectifiers. You guys got to do what you want to do, but I've just been having fun with them, and I thought you all might enjoy this. And the voltage now is 488, 489. What did I write down? I just wrote it down. I wrote down 488. And the power, let's get back to this part of it. Let's see, let's zoom in just a little bit just so we can see all the important stuff without touching it. Well, actually, I have touched it. I'm sorry. That's it right there, 1%. 24 watts, 24.07. We just call it 24. 24 watts. I haven't written that down yet. 24 watts. Okay, let me do one more little calculation here. The highest voltage was 512. And this one is 488. That's up. Oh, that didn't work. 512, 512, enter. 488 minus 24. 24 volts. Okay, now I got to show you the data sheet. I'm getting there. Okay, look here. The voltage with the 5V4 was 478. The 5U4 was 442. That's 36 volts of difference between these two. 5U4 is 36 volts less. The solid state diodes are 512. So there's 70 volts difference. That's quite a bit, isn't it? 70 volts difference between the solid state diode and the 5U4. And there's 24 volts difference between the solid state diodes and the Mercury Vapor Rectifier. Now, Mercury Vapor Rectifiers are supposed to have like about a 15 volt drop across the plates. I don't know if that's across each one, which would give us 30. Maybe that's where we get the 24. I don't know that. I'll have to look that up and verify it. Maybe you guys can figure it out. The voltage drop across diodes is like 0.7 volts, so there's no voltage drop there to any extent, so that's the highest voltage you're going to get. 5U4 is the lowest. The more current you draw through the 5U4, the greater this voltage drop is going to be as compared. We'll call this 0. For all purposes, this is a 0 voltage drop, 0.7 volts across each one. Yeah, that'd be 1.2. And the voltage across this one, if we half that, that'd be 12 volts. They say it's about 15, so maybe it's, in our case, maybe it's about 12 volts per plate. Okay, with the 5V4 478, we got 22 watts, 18.8, 26.45, and 24. So, whatever the voltage is, the power is pretty much in the middle. The highest was the 26, for the solid state diodes. The next highest was the MV rectifier. So it's closest to the diodes of any of them. And then the 5V4 at 22 watts, and then the 5U4 at 18.8 watts. This is real data. I've got no reason to make it anything except as perfect as I can get it. So whatever that's worth something, I think. Let me show you some things here. Here are the diodes lined up over here. I'm going to turn this thing off so I don't electrocute myself. Power it off, and let's pull the plug out of the back too. I'll show you underneath it a little bit. I was looking at it a little earlier. Interesting thing about this little probably like 60-year-old Heathkit amplifier. I don't know how well you can see it, but it's a Williamson design, and one of the things I notice about it is the values of the components, like the resistor values of 22K, the 470K, the 470 ohm, the 100 ohm, the 100K, etc. Those are the same as just about every Williamson design. Here's a 10K feedback resistor, in negative feedback, global feedback. It has no capacitor across it. Here's the cathode resistor. It is not bypassed with a capacitor. There are no bypass capacitors in the voltage amplifier section either. So that means you have local feedback at every stage. You have global feedback right here, and you have local feedback on every stage because you do not bypass the cathode capacitor with a capacitor. You do not bypass the cathode resistor with a capacitor. You do not bypass the cathode resistor here in the output stage either. So you've got a little bit of negative feedback, a little bit of negative feedback in every case. I think we do need to do one more little test. It does have a bottom on it. By the way, these are all original capacitors. Every one of them. And I'm not going to change them. Even this little capacitor right here is rated at 450 volts, 450 volts. I measure it's like 350 across it, like 336 or something like that. Fairly low, you know, in a safe range. Even with the diode in it, even with 512 volts. I think we do need to run one kind of a test here. Again, because I want you to see how well this thing actually performs. Whoa, that wasn't good. Did you see that? I don't know if you saw that in the camera or not, but it flashed. You know what I need to do? Yeah, well, you see, there's the curse of the MV rectifier. I'm actually kind of glad it did that. It has warmed up. I don't think there's any mercury on the cathode, but I guess the voltage in it is high enough that probably should let it warm up. I need to put maybe some sort of a little thermal relay tube in it, either that or another. Make it complicated now. Power it up, let it warm up for a while, and you could press a button with a holding relay to turn the high voltage on. Holy cow. Yeah, I did see it flash inside. I actually hope you saw that, because that's what happened. Okay, let's run a little bit of a test on it. And let's run it at, say, okay, since we got the MV rectifier in it, it does 24 volts, watts. Let's run it at 20 watts. And we'll put this little devil to the test here. Let me get right in front of this again. You see this on a lot of my videos. Here's something I've been running earlier. I'm going to close all of these because we don't need any of that. And I'll crank it up to 20 watts. Do you want to exit? Yeah, I sure do. And I want to exit this one too. Yep, I sure do. Okay, and then we'll start THD. This is the Pete Millett program. Sorry, I'll get it here in a minute. I'll get you all scoped in. I got to get right in front of it, so I can scope in on the camera the best, and you can see all of it at once. I'm going to move it back up to the 8903. I always set the points per decade at 10. I think it needs to be about 0.8 volts. And then I say start. Now look over here. And the output is 20.7 watts. I want you to see it. See that 20 right there? That's our power. We're going to be testing that. And excuse me for banging it around, but everything's in the way. Everything's in my way here. Okay, and then we're going to say yes. Reference level okay, yes. I think for pretty much a 60-year-old amplifier, I think it does pretty darn good. There it is, about 0.9% at 20 hertz. Drops down right quick to about 0.7. And let's see how it does out at the high end. I think I was testing it a while ago at like 24 watts. And out at about 20 kilohertz, it didn't do so well. Just didn't do so well at all. Let me get this thing nice and straight for you. But that's a nice flat curve there. And then we're running down at maybe 15 or 16 watts on the second scan. Yeah, the Mercury rectifier flashed a while ago. I didn't like that. I'm not exactly sure what I'm going to do about that. In some of my amplifiers, I use these little delay relay tubes. They come in 9-pin version and an octal version. And like if the number is like just for example, 180 NO 120. The 180 means 180 seconds, 3 minutes. NO means normally open, and the 120 means that the filament needs 120 volts. So you can put it right across the AC line. You know what? There is an anomaly in this amplifier. I've seen that too many times right there. I've seen this almost every time. Right up there at about 20 kilohertz. See, this is 25 kilohertz. Out here at the very end. So just at about maybe 18 or 19 kilohertz, there is an anomaly out there. I thought that was something in the program, but I don't think so. I see it every time. Okay, let's open up another session. And in this time, I had that at 0.8. We set our decades, point per decade to 10 again. And instead of saying at 0.8 volts, let's run it at, like, say, 0.75. And let's see what the power is. I hope you'll just trust me on this. It is exactly 18.3 watts. Let's lower it just a little bit. Let's make it 0.72. I want to get it down to about 16 watts. That's 16.93 watts. And let's say, okay. And see how this runs. I don't see it at the low enough power. Yeah, see the THD dropped a little bit there at 20 hertz down to about 0.7. Now it's all below 0.5%. That's my pliers here, and open myself something to cool off. Everybody needs to stay cool, don't you think? 0.5%, 16.9 watts. Let's see if we see that anomaly out there at about 20 kilohertz. I was seeing that earlier with like the 5V4. I don't think I ran these tests with the 5V4. It doesn't make any difference. The vacuum rectifiers. I'm sure the vacuum rectifiers, solid state rectifiers, or the MV rectifier is not going to have anything to do with that. The rectifier itself, the voltage might. But I have a tendency to believe that it's some sort of a little glitch in the circuitry. See it? got the tiniest little bit right there. Isn't that interesting? Just the tiniest little bit. But it is, man, that is flat. I mean, that is so insignificant out there. But at 16 watts, that thing is stellar. That's right out of, that is just absolutely magnificent, I think. For a little, excuse me, for a little wacky 807 amplifier. Heathkit WA-1. They made some good stuff back here. That little peerless transformer I'm actually quite impressed with. Seems to be quite good. And there's our pretty little MV rectifier again. Well, for what it's worth, that's it. It's testing different rectifiers from one extreme to the other, solid state to vacuum rectifiers to Mercury Vapour rectifiers. If you plan on experimenting with some of this in your own equipment, you must make sure that no matter what you put in there, you don't exceed the voltage rating of your power supply capacitors. I said I would show you this. Let me show you underneath this. Let me turn this off. I do want to stay alive. Pull out the AC cord. I'm going to unplug all of it just so I can handle it better. I've shown this amplifier before. It's actually quite simple. I use the IEC type AC plug here, fuse, and there's my DC filaments and ground or what have you. It's got a hum balance right over here that we're not going to get into. But underneath, it's very simple. But I use 25 volt, 800 volt capacitors. I like my capacitors to be well rated. You know, let's say your capacitors are rated at 525 volts and your amplifier is running at 480. Well, that's good. That's a little bit of a margin. And it's running a 5U4. You're in good shape. But you go around and plug in a solid state rectifier, and as you saw from the data that we just collected, I'm using these same numbers. I'm using 480 volts. Well, that's 440 with a, let's say it's 480 with a 5U4. Anyway, you're going to get about a 70 volt increase or a 5U4, so you're going to get even more than that. It's going to over voltage your capacitors. Now, if you're the tinkering type and the one that'll change them, you can put capacitors in series, you know. You put them in series like batteries, plus to minus, and you have to shunt them with a resistor. If you use 450 volt capacitors and you want to dissipate 1 watt, you can do all this little bit of algebra of Ohm's law. You'd use like a 220K 1 watt resistor. I'd put a 220K 2 watt resistor in there. So that means that no matter how high the voltage gets, assuming it's not exceeding the 450 volts, if you put two 450 volt capacitors in series, you got a 900 volt capacitor. Now you're safe. This is not hard to do. Just you can these right here have a little stick-em-on connector, and then I have you know, the cable ties around them. In a lot of cases, when I put capacitors in, I goop them in with a little bit of goop. Not everybody knows about goop for some reason, and it's just stuff right here. It's all the same stuff. Here's some more of it. E6000. It's just a really industrial adhesive, and you can pull it off. Now, I will say this: if you use these type of capacitors, if this is the one that the negative side is to ground, you can glue this right straight to it, right straight to the chassis. But if this is the one that's the top capacitor, where it's got the 900 volts on it, so to speak, you really need to put a little bit more insulation here than just a goop, because I've had them arc Maybe you could use double-sided tape. Some really high-quality double-sided tape would probably be thick enough to put on here and just stick it in there like that. I do that all the time. I put as many as like 12 of these things in series. See, 10 of them is going to give you 4,500 volts. 12 of them will give you 5,200 volts. I use those in my power supplies for my RF amplifiers. Works. And then shunt each one. Like I say, with a 220K 2 watt, or you don't have to have 220K. I think in a lot of cases I'll use like 470K. All you're trying to do is each time you put these things in series, plus to minus, just like you stack batteries in series, you put the resistor across each one and then link this one to the next one and a battery, a resistor across it and so on. The reason for that is the resistance of these things are going to vary, either brand new or over time, but that resistor across them equalizes the voltage, so every capacitor gets the same amount of voltage. So if you've got 1,000 volts across them, then you get 500 across each one, or whatever. So in the old days, electrolytic capacitors were just too darned expensive, and the big plastic, there's a company called Plastic Capacitor that makes really good high-end stuff, but then they're those great big monstrous maybe 6 microfarad 6,000 volt oil capacitors. They're great, but they're huge. So you can build power supplies with all kinds of voltage levels and make it quite small. See, there's the 4-pin socket. By the way, I only use military surplus type sockets. These sockets that are made nowadays in the foreign countries, see, like this one right here, this is not a foreign country, this is a military surplus one. I mean, this thing's probably 60 years old, almost as old as me. And boy, I'm telling you, these things will hold the tube in there and it won't fall out and it won't work loose. Anyway, I hope this entertains you, and it might be worth something. Thanks for watching and stay safe. Okay, one more thing. As usual, I can anticipate somebody asking, what is the high voltage winding of that power transformer? Well, let me rattle on here just another second. Look here. This thing says 1,000 volts DC or 750 volts AC to ground. It means across it. And I've learned, I have smoked Tektronix meters and I've smoked Fluke meters. I'm not proud of that. But this is half of it, 411 volts, 412. So double that and you've got the voltage across it. That would be 822 volts. So it's 822 volts center tapped is what the high voltage rating of that power transformer is, and then you can figure out from there with those DC voltages that I've shown you what you get with different rectifiers with an 822 volt transformer. I guess it's probably rated at 800 volts or something like that. There you go. Just thought that might be important. Didn't want to leave out an important piece of information.